Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. This question is another example of applying Newton's laws to solve problems. This question is from AP Exam 1988, Mechanics question number 1. A highway curve that has a radius of curvature of 100 meters is banked at an angle 15 degrees as shown, like the picture. Question 1. Determine the vehicle speed for which this curve is appropriate if there is no friction between the road and tires of the vehicle. So in order to determine the speed, we have to first, let's take a look at the situation. Here is a car. It's going around. So because it's going in a circle, there has to be a centripetal force. So this basically, if you find a centripetal force, then you know centripetal acceleration, then that's how you can find the speed. So in order to find the centripetal force, we have to do a free body diagram. What is the force producing the centripetal force in this case? So let's take a look at all the forces acting on a car. First, you have normal force. By the way, this is the angle, right? Besides that, you have gravity. That's it, because there's no friction. So because acceleration in this case is to the left, so acceleration has to come from part of the n, components of the normal force n. So let's take a look, because this angle is theta. So over here is theta. We draw a little triangle there. That means the sine component, the opposite, that's the sine component of n, is the one that's producing centripetal force. Then the cosine component of n is the one that's overcome gravity. So the car does not move up and down in this coordinate. So from Newton's second law, we have all the forces in the x direction. If we take a look at this x is in the same direction as a, then we have n times sine theta. That's the one that's gives us the net force, and that's the one that's produced centripetal acceleration. So MAC equals mv squared over r. And n cosine theta equals mg, so upward equals downward force. So to solve for v, we can divide the two equations. When we divide it, we have n sine theta divided by n cosine theta equals mv squared over r divided by mg. We can simplify the equations on the right. We have mv squared divided by mg r on the bottom. So n and n cancel, m and m cancel. We have v equals to square root of gr times tangent theta. Plug all the numbers in. G is 9.8, r is 100, theta equals to 15 degrees, so we have 16 meters per second. That's a question number 1. Question number 2. On a dry day, when friction is present, an automobile successfully negotiates a curve at a speed of 25 meters per second. So when there is friction, you can drive faster. You probably all experience this in real life, because when it rains or snows, you have, especially around a curve, you have to drive very slow in order to negotiate a curve. That is because the friction is very small during those conditions. But on a sunny day, dry day, you can drive a little bit faster. On the diagram below, in which the block represent automobile, draw and label all the forces on the automobile. So again, this you still have normal force, you still have gravity, but now you also have a friction. This, as a matter of fact, is static friction. And this static friction provided more centripetal force, and therefore you are able to have greater acceleration. As a result, your speed can be greater. Now let's go to next part. Determine the minimum value of the coefficient of friction necessary to keep this automobile from sliding as it goes around the curve. To find the coefficient of friction, we have mu equals F over N. To find mu, we need to find F and N. So to find the force of friction and the normal force, we need a free body diagram. So here's a free body diagram. We have to choose our coordinates. X is to the left because that's the direction of acceleration, and Y is going upward. So from Newton's second law, we have force in the y direction has to be 0 because the car is not going up and down. Force in the x direction, the net force produces centripetal acceleration. So sum of Fx equals max. Force in the y direction equals 0. That means upward force equals downward force. Upward force is the ny, which is n cosine theta. Downward force is F sine theta plus mg. Now the force in the x direction, positive x direction, is F cosine theta plus n sine theta. And that's the two forces added together gives us the net force, produces centripetal acceleration. So to find F and n, we need to solve these two equations. Two equations, two variables, F and n. So in the next part, it basically is just algebra, how to solve F and n. From the top part, we solve n equals F sine theta plus mg divided by cosine theta. Then we plug this expression into the second equation, F cosine theta plus F sine theta plus mg cosine theta times sine theta equals mac. To add, this part has a fraction, so we have to change the first term in fraction term, which is F cosine theta squared divided by cosine theta. Now add the two fractions together, we have common denominator. So that's the first term. The second term, I simply distributed the sine theta with F sine theta plus mg. So that becomes F sine theta squared plus mg sine theta. That total together equals mc. As you can see, these two terms, F cosine theta squared plus F sine theta squared, this is just F. So that becomes F plus mg sine theta. Divided by cosine theta equals mac. We multiply cosine theta on both parts, so the top becomes F plus mg sine theta. That equals mac cosine theta. So F really equals mac cosine theta minus mg sine theta. I can factor in m out. That becomes ac cosine m times ac cosine theta minus g sine theta. That is F. Now we have to solve for n. To solve for n, we need to plug the F in this equation. So that equals to F equals mac cosine theta minus mg sine theta times sine theta plus mg. Distribute sine theta to both terms. That becomes mac cosine theta times sine theta minus mg sine theta squared plus mg. I factor in mg out, so the second term becomes 1 minus sine theta squared. 1 minus sine theta squared equals to cosine theta squared. So as you can see, all the terms has cosine theta. We can cancel out cosine theta. So this becomes n equals to m. Factoring it out, ac sine theta plus g cosine theta. Now we have both f and n, we can find mu. Mu equals s. F over n is just m and m cancel out. The top have ac cosine theta minus g sine theta. On the denominator, we have ac sine theta plus g cosine theta. Next part, what is AC? AC equals v squared over r. That's a centripetal acceleration. That gives 6.25. So the next part, simply plug all the numbers in. Mu equals to 6.25 cosine 15 degrees minus 9.8 sine 15 degrees divided by 6.25 cosine 15 degrees plus 9.8 sine 15 degrees. And that gives us mu equals to 0.32. Okay, that's it. I know it's complicated in math, so you just have to be patient and take your time to figure it out. I hope it helps. Thanks for watching.